everyone, welcome to AgroStructure. Today you all are with me to dive into the third video of our scheduled playlist. So, what is heap? A heap is a special type of binary tree that satisfies the heap property. It is commonly implemented as a binary heap using an array. Heaps are powerful data structures used in a variety of domains for real-time processing to optimization problems. Their ability to handle priority-based operations in 0 log n time makes them ideal for scenarios where efficient retrieval of the smallest and the largest element is crucial. To create a heap from a binary tree, the parent node of the tree is either greater than or less than the child node. Heap properties. Complete binary tree. The properties of complete binary tree is also aligned with the heap tree. In complete binary tree, there are three things that we have to look at. First, every level except the possibility last is completely filled. Second, all nodes appears by filling left to right. Third, except the leaf nodes, every other parent must have two children. Look at the given image of the complete binary tree. It processes all the properties to become a heap tree. A heap tree is always a complete binary tree, meaning all levels are fully filled except the possibility last level, which is filled from left to right. Second, heap order property. There are two types of heap based on the order property. Max heap. The parent node is always greater than to its children. The given heap is in the slide is a max heap. All the children nodes are less than the parent node, which is 6. Min heap. The is always less than to its children. The given heap in the slide is min heap. All the children are greater than the parent node, which is 1. Elements in a binary tree to maintain the heap property. When an element violates this property, we use heapify to restore the heap structure. Why do we need heapify? We need heapify to ensure that the heap property is maintained after the insertion or deletion of elements. After insertion, when adding a new element, heapify up ensure the new element is placed correctly. After deletion, when removing the root, heapify down restores the heap order. Heapify up or bubble up happens after insertion to restore heap order. Moves upwards in the heap by swapping with the parent if needed. Down heap. Heapify down, sink down. Happens after deleting the root to restore heap order. Moves downwards in the heap by swapping with the largest or smallest child if needed. In short, up heap is equal heapify up fixes violations after insertion. Down heap equal heapify down heapify down fixes violations after deletion. Properties. There are main two key operations in heap tree. First, insertion. Second, deletion of the root. Let's look at insertion. Insertion in a heap. Inserting an element into a heap requires maintaining the heap property. This is done using the up heap as we discussed earlier. Steps to insert an element into a heap. Insert the element at the end. Last available position in the heap. Compare with its parent. If the heap is min heap, Swap if the new element is smaller than its parent. If the heap is a max heap, swap if the new element is larger than its parent. Repeat step 2 until the element is in the correct position or it becomes the root. Or it becomes the root. Code implementation of insertion operation. So look at the code. It shows how we have implemented the insertion operation with this. So in the insert function, int value takes an integer value as the input, which is the new element to insert into the heap. In the in the if operation, it checks the heap is full. Size equal heap dot length. If the number of elements size is equal to the array length, heap dot length. The heap is full. Throws new illegal state exception. Heap is full. So it prevents the overflow. If the heap is not full, it checks the heap size equal value. Then insert value at the next available position end of the heap. The size is index where the new element is placed. Size is the index where the new element is placed. Heapify up size function. This function calls heapify up to fix any violations of the heap property. Heapify up size function moves the element up if necessary. In a binary heap, deletion always removes the root, the highest priority element. To maintain the heap property, we use the down heapify down method as we discussed earlier. Steps to delete an element from a heap. Removes the root, the first element. Move the last element to the root. And then we have to do the heapify down and compare the new root with its children, swap with the smallest or largest child if needed. Repeat until the heap property is reached. So this is the code implementation of delete operation. This is how you have to use Java language to implement code segment for the deletion of heap. So look at the remove operation. This method removes the root, the highest priority element, and maintains the heap structure. So with that, there is a if condition. With the if condition, it checks the size equals 0. If the size equals 0, it throws an illegal state exception, which is heap is empty. Here it checks the heap is empty or not. If size equals 0, if there are no element, it throws an error to prevent removal. So then int root where heap becomes 0 stores the root element. This is where we store the root element. If that is a smallest element in a min heap, it is the largest element in the max heap as the root. So root is always at heap array as 0th position. So heap 0, heap minus sign. There what is done is replace the root with the last element of the heap. It decreases minus size decreases the size first and removes the last element. It removes the last element. Heap 0 this and equal heap size removes the last element to the root position. It moves the last element to the root position, and the last element is not deleted, but it will be overridden in the next insertion. and then it is done the heapify down 0. It calls the heapify down 0 to fix the heap property after replacing the root. Since the new root might be incorrect, heapify down moves it to the correct position. Return root, that returns the original root, the removed element. And the method heapify down, this method restores the heap property by moving the new root down if method if needed. With that, there is a while loop also in the heapify down method. In that while loop, it runs an infinite loop until the correct position is found, and there are two variables have declared as left and right. Left assign the left child index and the right assign the right child index, and there is another variable called extreme. It is assign the index of the index, finds the left and right child. It finds the right and left child indices of index, and here left equal left child index. There find the left child index 2 multiplied by index plus 1, and the right equal right assign right child index. It finds the right child index 2 multiplied by index plus 2, and the what is done by extreme it assigns the index, and it assumes the current node as index is in the correct position. Index is in the correct position. If left there is a if a part also. With the if part, it checks that it compares left and right children with heap extreme, and there is a compare also. It checks if the left child is smaller or larger, and then update the extreme into left. Similarly, it checks the right child and updates extreme right, and there is a swap operation. It swaps the current node with the smallest or largest child, and there is a index there is assign that extreme is assigned the extreme assign the index at there it moves the index to extreme and continues heapify down until the heap is fixed. The extreme variable here, the extreme variable is used to track the correct position of the element being heapified. So this is a code segment which shows how to build a max heap or min heap from an array. So there is a method called build heap. It converts an unsorted array into a valid heap. It starts from the last non-leaf node and heapifies each node upwards. The heapify process fixes violations and restores the heap property as we discussed earlier. So with that, I think you all get good understanding about heaps. In the next video, let's learn even more together. Until then, subscribe us and click the bell icon to wait. I sincerely ask for your cooperation. Thank you so much for watching us. Bye bye.